So like I was saying earlier, I don't have a whole lot to go over. Of course, we've heard that before. Let's not forget things like this. I think this marker's about had it too. But this will work. Does that show up on there? Yeah, it does. So let's not forget some of these, okay? Just a name. Yep. Phenol or hydroxybenzene, okay? Then we talked about this one yesterday, okay? Aniline or aminobenzene, okay? So 2 down, 2 to go. What's another common name aromatic? Okay, so did you two say this the same? Well, it's the same compound, just different ways. Is that right? Okay, so if we wanted to say methylbenzene, what's another name for that? So here's your methyl group, and then that is, of course. Okay, so and I don't know if toluene or toluene. Toluene's always made more sense to me, but we know what you mean when we say toluene. Isn't there a university in Louisiana? Is it Tulane then? Yeah. Okay. All right. And then the last and final common name is which one? And when you see it, that's the main idea, okay? Right. And there's a multitude of ways that you could write something like that. You could put the double bond on the bottom. You can do this as well, okay? That means the same thing. Yeah. Too bad there's not an L in there, so we can say, this is cool, right? Yeah. Yep. Okay. So then, don't forget our common names. Then, what about, we're going to show you how we have a blast. Yeah, you'll believe me when I say this. Just like when you look at your physics formula, we can say that work makes you mad. Do you remember that? Got a t-shirt that says that too. Okay? So, and this will be quick, okay? From physical science, we agree with that, right? Force equals a mass times acceleration. What does work equal? You're 2 steps ahead of me already, but work is force times distance, of course. Then we substitute these equal values, attach that to the end, then, yeah. So work can make you mad. All right. So back to this. Let's say if we wanted to start from benzene, okay? We want to make toluene from this, okay? And how could or would we go about doing that? That's what you need to do, okay? So what you're saying, you're about 90% right, okay? So this is true. We want this to get on that ring. That's right. But then, again, and your chart would tell you this. What variable is that? Is that an alkyl group? Yes, and alkyl groups have what variable then? Yeah, this would be an R group. And then on your chart, it says R and X. If we want this R group to be attached on here, we would say methyl, but this is unstable. it only has 3 bonds, so it needs one more. And that's where the fourth bond comes from, the X, which is a what then? A variable for what? Yeah, which is a halogen, any halogen. So then what you could do, you could even say methyl bromide, okay? Methyl chloride, methyl iodide. I said fluoride, chloride, bromide, and iodide. So here's our R, here's our X, okay? Then we've got a catalyst of some sort, which we'll just say, I don't know, some aluminum bromide. Because typically, for our purposes, and it's my understanding, when you do this, these usually match up. I suppose you could use some aluminum chloride, but to me it just makes the most sense. Whatever it is you have for a negative charge here is what you would put on here. So now we know this is going to react. This then gets attached onto there. Okay. And then there's our methyl group. There's our toluene. Okay. Well, what would happen now if we did this then? Okay. So every time I look at that, I say, oh no, or ho no, or something like that. Ho no? Is that? It's nitric acid, but we learned this is just HONO2. So when that gets added on there, and your catalyst, which is sulfuric acid now, is that going to react? Well, chances are it will, because you have your catalyst. Then, according to this, okay, what's going to happen when that attaches? Will it attach? Yes, it will. So then, this is where, of course, maybe I'm writing too big, and then we're going to have to go over like this, okay? So we still have our toluene, okay? So what from this compound, the OH or the NO2 or just the nitrogen, just the oxygen, just the hydrogen, what's going to attach on that ring? Okay? Just pick a spot or, okay? So we're saying down here. Okay? That's correct. Because remember, for our purposes, even like yesterday, we said it's what is on that ring is going to continue to direct what's going to go on there. So then this is going to tell that nitro group to attach. Yeah. Okay. So just go ahead and pick one. We're going to do both of them, but which one would you want to see first? That's what I'm saying. Okay, so then the ortho position. So then we would attach that on there. Okay? But then, is that the only product that we would get? Okay, so then we would get this here as well. And then all the way down there. Okay? So let's expand upon this that we had learned yesterday, because what we did yesterday was say, okay, somewhere along these lines, maybe there's not a lot of this, but then this gets to be in excess. So then what we'd want you to know from that is just going to keep right on going. It's just going to keep right on let's say, attaching to this ring when we get to this step until all spots are filled. And that's what we did yesterday, because I think we had chlorine on there, right? And we talked about lindane, but lindane's not from an aromatic structure. But first of all, do we remember that conversation? Yes, okay. So now we're going to change this just a little bit. We're not going to totally reinvent the wheel, because this is correct, and we know that that's correct because this wasn't in excess. But now if we tell you that it is, okay, from what we learned yesterday, this might not be the only product that we would presume. So what that means then is, okay, where would we possibly attach another group on here? Okay, which is, now, and you are right, but I want you to know why you're right. Because you said bottom, which you're right, but why would we not go a pair of position from that one? You're saying from this, which is correct. Why not this one? That's true. But which one was on there first? Yeah, the methyl group was on there first. So that is going to be kind of like a traffic director where, oh, you stop, then you go. Have you ever come across an intersection where there's a policeman or someone directing the traffic? Okay, so then that's kind of what you could say this methyl group is doing with this, making this compound, is saying, you go here. Okay, we've got more of this. You go down here. Okay? Okay? Then, because this was on there first, again, is there still any availability for attachments on this ring? Yes. And it's to where? We doing the cha-cha, to the left, to the left, to the Isn't that the cha-cha or something like that? Okay, okay. Sorry. So when you say to the left, that means could it be here or could it be here? Yeah, so it's up here. Now, to me, which of these two elements is really attaching to the ring? Is it the oxygen or is it the nitrogen? And this looks silly, I know. But to me, you'd either do it, and this looks kind of silly, I think. But technically, that would be right. But to me, it would be more for our purposes. I think it makes more sense that you attach the nitrogen, then the oxygen's attached like that.
Didn't it yesterday when we did this though, you had 3 different aromatic things? Like you had 3 different. Like the first one had the ortho, the second one had the para and the ortho, and then the third one had all 3 of them.
Okay, I need to think about that for just a moment. Okay. To me, I think yesterday we wanted to show this in 3 separate steps just to say this is how it's going to attach, because this is an excess. It's going to take, okay, this one's first, then this one's second, then we would add one more, okay? That's correct. Maybe take this in phases, and then, and I know this looks silly, but I'm standing to the side here. And then, so with that one was on, this one was on, and then finally there's our last one. Yes? You don't necessarily have to do all 3 of these steps. You can just go to the last one. You can do that too. But that is only when? Only if you see that this is in excess. That just means that you have all this nitric acid. It's just going to keep right on attaching to the availability that it can. Okay? But you also have to take into account, you have to start with this guy here because that was on there first. So that's directing the traffic, okay? So then to possibly say we could wrap this up is, what are these groups called, these NO2s? Yeah, what is an NO2 group called? Not nitrate, nitro, okay? So then, and how many of those nitro groups do you have? Okay, so then what means having three? If you had three methyl groups, you had three chloro groups, okay? So then this is the compound we just illustrated, trinitrotoluene, okay? Wile E. Coyote would be proud because we can abbreviate this because we got a T, an N, and another T. So you wouldn't just necessarily write this out. You could just say we've got trinitrotoluene. That's where that comes from. So I don't know, maybe Wile E. Coyote's down in his basement. He's making all of this reactions here and comes up with trinitrotoluene. That's actually TNT. That's why didn't I tell you we're going to have a blast? See? This is a blast. Boom. Isn't that what you say? Isn't that mind blown? Maybe. Okay, so, because we can look at this just a moment here. So I finally did track it down. And if you could say trinitrotoluene, or you could say 2,4,6, okay, trinitrotoluene, because remember, when you're naming these, this takes the priority as number 1 because you're calling it toluene. So 2, 4, and then 6. So, all right. So that's really all I have. The aliphatic reactions and naming, okay, those are straight chains. Sometimes you have the symmetrical reagent, the symmetrical compound, okay? And then sometimes you get two products, sometimes you don't. You also have, again, naming the aromatics and then the reactions that accompany them as well. Anything else? Oh, what do you mean, bonus? All right, I guess I got to come up with a couple questions here. Okay, so just to try to make sense of this in case you have to come back. The world headquarters for John Deere is in Moline, Illinois, but on the east side of Iowa, there's a fairly large plant for John Deere. And whether it's on the Mississippi, that I'm not quite sure of our geography. I just know it's on the east side. And then for combining purposes, New Holland, maybe make a decent combine because they are TR series. What does TR stand for that of New Holland's? Okay, so we will begin our evaluations tomorrow and Friday. We'll catch up to you next time.